Caloric homeostasis or energy homeostasis is a signaling pathway to tell you if you are hungry. It's being classified as short-term signals and long-term signals. The GLP-1, CCK, and this, so on and so forth, are all hormones. These hormones, the short-term signal molecules like GLP-1, CCK, or ghrelin, they all secreted from the intestine or stomach. Ghrelin is secreted from stomach. The GLP-1 is secreted by the intestine cell. Is around 30 amino acid in length. This is being secreted from the intestine, so as a hormone to transfer to the brain, being detected by a GPCR receptor in hypothalamus. The GLP-1 will tell the brain you got enough food, you won't stop eating. CCK as well is a family of peptide hormones. It's a protein as well. It's 8 to 58 amino acids in length. It is also being secreted from the small intestine, and the CCK receptor is in the brain as well. It tells the brain you're satisfied, you got enough food in your stomach, and you want to stop eating. These are all signal molecules or all hormones to tell you stop eating, you got enough food, like glucose, like peptide 1 we discussed previously, GLP-1 and GLP-2, and so on and so forth. We discover a limited number of hormones that allow you to feel hungry, which is ghrelin. Ghrelin is a 28 amino acid in length hormone secreted by stomach. Then also the receptor is a GPCR receptor in hypothalamus in brain. Long-term signals as far as I know, only 2 long-term signal molecules. One is a leptin, the other is insulin. As we know, the insulin is a hormone to regulate the glucose level in the blood, but it also be known as a long-term signal to allow you to feel satisfied. The leptin is a hormone that's been secreted by the adipocytes. The adipocytes are cells that store the fats, also be known as the fat cells. A large fat cell will secrete more leptin. The fat cell number in human will not increase or decrease. You become fat is because the adipocyte is bigger. So the big adipocytes secrete more leptin. Leptin will trigger a signal. Leptin is a hormone molecule. Actually, it's a second hormone, being classified as a second hormone. It will secreted by adipocytes and transfer to the blood and affect the I forgot, hypothelium. So will affect the hypothelium in brain to tell you you're full. Basically, there are more fats, more leptin in the blood. That means if you get a lot of, you become fat, you will not feel hungry in theory, but actually it's not. When you get fat, you got leptin resistant. That means you need higher level of leptin to make you feel hungry. It has a similar it's same as insulin. Because insulin continue to have high level of insulin will develop insulin resistance. Someone says they have same mechanism. The leptin resistant and the insulin resistant have similar mechanism to be triggered. So that will have similar mechanism with type 2 diabetes. So that's why we're interested in that. And the insulin as well. But here's more detail. When the fat cell mass increase, the leptin expression increase. Then it will activate the neuron cell in hypothelium. This neuron called POMC neuron. The POMC neuron will secrete a hormone called MSH. The MSH hormone will tell you you are satisfied. That means you decrease your food intake. Insulin as well. When the glucose level increase, you secrete more insulin, and the insulin will make you feel satisfied. It's similar to the pathway here. Similar to the pathway of leptin, make you feel satisfied. The insulin will also, there is an insulin receptor in hypothelium as well. The insulin will make you satisfied. Okay, that's all. I think it have enough information to tell you for the caloric homeostasis. Stop.